Hey everyone, and welcome! Today we're going to tackle a programming concept that you will use all the time. I'm talking about typecasting. So let me ask you a question. What do you do when your data needs to, well, change its shape? You've got a whole number, but you really need it to be a decimal. Or maybe you've got this general vague object, but you know it's something more specific. How do you handle that? Well, that's exactly what typecasting is for. All right, so let's get right down to it. What even is typecasting? The easiest way to think about it is like giving a variable a new identity. You're basically letting it pretend to be a different type to get a job done. Fundamentally, it's actually pretty straightforward. All we're doing is taking a value, say an integer, and telling the compiler, hey, for a minute, I need you to treat this thing as a decimal number. Now, the key here is that the types have to be compatible. You can't just turn a number into, a JPEG image, right? But you can absolutely convert between different kinds of numbers or between objects that are related to each other. Okay, so there are a couple of ways to pull this off. Let's start with the easy one, the one you don't even have to think about. It's called implicit casting. This is kind of the hands-off approach where the compiler is just smart enough to figure it out and do all the work for you. And I love this analogy for it. Just picture this. You're pouring water from a small cup into a giant bucket. Are you going to lose any water? No way! It all fits perfectly, with plenty of room to spare. That is the whole idea behind implicit casting. And the reason it's so easy is that it follows some really simple rules. First, it happens totally automatically. You don't have to write any special code. It's always going from a smaller, less precise type to a bigger, more spacious one. And the best part? It's guaranteed to be safe. There is absolutely zero risk of losing any of your precious data. Okay, let's look at a super simple code example. We've got an integer, num, and it's equal to 10. Then we just assign it to a double called d. Now, a double is built to hold decimal numbers, so it's way bigger and has more precision than an int. The compiler sees this and thinks, oh, easy, a small cup into a big bucket. I can handle that. And boom, it automatically converts the integer 10 into the double 10.0 for you. It's that simple. But what happens if we want to go the other way? What if we have that big bucket of water and we need to pour it back into that tiny little cup? Well, things get a little trickier. That's when you have to take control, and we call that explicit casting. And this comparison right here really gets to the heart of the matter. Implicit casting, that's the automatic, totally safe, small cup to big bucket scenario. But explicit casting, that's manual. It's risky. That's you trying to pour from the big bucket back into the small cup, and you've got to be prepared to spill a little or a lot. So for instance, let's say our big bucket is holding the value 9.8. It's got that nice precise decimal point and everything. Okay, so what happens when we try to force that into our small cup, an integer, which can only hold whole numbers? Well, the 0.8 just disappears. It gets chopped right off. And notice, it's not rounded up to 10. It's truncated, which means it's just thrown away. That's data loss, and that's exactly why the compiler makes you do it manually. You have to tell it, yep, I know I'm about to lose some information here, and I'm doing it on purpose. So how do you signal your intent? How do you tell the compiler, I'm serious about this? You use this very specific syntax. You put the data type you want, in parentheses, right in front of the variable you're converting. That int you see there, that's you, the programmer, putting your hand up and saying, I'm taking full responsibility for this. Force the conversion, I know what I'm doing. All right, so we've been talking a lot about numbers, but casting is so much bigger than that. These exact same principles, the safe way and the risky way, apply when we're working with much more complex things, like objects. You see this all the time when you're dealing with class inheritance. You might have a variable that's a really general parent type, like object, but deep down, you know it's actually holding something more specific, like a string. This is like the big bucket to small cup problem again. To use all the cool, specific features of a string, you have to explicitly cast it back down from the general object to the specific string. Check out this code. We've got a variable object of type object, but we've put the text hello into it. As far as the compiler is concerned, object is just a plain generic object. It has no idea about string-specific things like .toUpper or .length. So if we want to treat it like the string it really is, we have to cast it. That string is us telling the compiler, hey, trust me on this one. I know it looks like a generic object, but it's secretly a string inside. And this brings us to a really, really important question. What if you're wrong? What if that object wasn't a string? What if it was a number or something else entirely? If you try to force that cast, your program is going to come to a screeching halt. It'll crash. And in the world of professional software, crashing is, well, it's not an option. Fortunately, the language gives us a much safer way to handle these exact situations where we're not 100% sure. We get two incredibly useful keywords, is and as. Think of these as your seatbelt and airbag. They're your tools for casting defensively. So here's the workflow the pros use. First, you can use the is keyword. It's like asking a simple yes or no question. Hey, compiler, is this object convertible to a string? It'll just give you back true or false. But what's often even more useful is the as keyword. As tries to perform the conversion. If it succeeds, awesome, you get your converted object. But if it fails, no crash. Instead, it just gracefully gives you back null. And null is something we can easily and safely check for in our code. And this right here is the gold standard for safe casting. You'll see this pattern everywhere. First, you try the cast using as. Then, the very next thing you do is check. If s equals null. If it's not null, you know the cast was a success, and you can safely run all your code inside that f block. If it was null, the code just gets skipped. No muss, no fuss, and most importantly, no more crashes. Okay, that was a whirlwind tour, right? We've covered a ton. So let's pull it all together into a handy little toolkit. Think of this as your go-to cheat sheet for picking the right casting method for any situation. It really breaks down into three choices. For those 100% safe, small cup to big bucket conversions, let implicit casting do the work automatically. When you absolutely must force a conversion, and you're fully aware that you might lose some data, that's when you use explicit casting with the type syntax. And finally, for any situation where you're not totally sure if a cast will succeed, always reach for the safe operators, is and as, because avoiding a crash is your top priority. When you boil it all down, typecasting is really about giving you, the developer, more control and flexibility. It's a powerful tool that lets you look at the same piece of data in different ways to solve really interesting and complex problems. So that just leaves one final thought for you to take away. Now that you understand how to change a variable's identity, what kind of powerful and flexible code are you going to build?